Neural networks algorithm. The top function in neural networks is a crucial component that plays a significant role in their overall performance and effectiveness. In this explanation, I will outline the key aspects of the top function and its importance in neural network algorithms within a 1,000-word limit. Neural networks are computational models inspired by the human brain's structure and functionality. They are widely used in various fields, including machine learning, computer vision, natural language processing, and many others. The fundamental building blocks of neural networks are artificial neurons, also known as nodes or units, which are interconnected to form layers. These layers are organized into an input layer, one or more hidden layers, and an output layer. The top function refers to the activation function used in the output layer of a neural network. It is responsible for mapping the final layer's input to a desired output or prediction. The choice of the top function depends on the problem at hand and the specific requirements of the neural network model. 1. Identity function. One of the simplest top functions is the identity function, which directly passes the input through to the output. It is often used in regression tasks where the network's output is expected to be a continuous value without any transformation. 2. Sigmoid function. The sigmoid function is a popular choice for binary classification problems. It squashes the input to a range between 0 and 1, representing the probability of the input belonging to a particular class. The sigmoid function has a smooth, S-shaped curve, which allows for smooth gradient-based optimization during training. 3. Softmax function. The softmax function is commonly used in multi-class classification tasks. It takes a vector of arbitrary real-valued scores as input and converts them into probabilities that sum up to 1. Each element in the output vector represents the probability of the input belonging to a specific class. The softmax function is especially useful when dealing with mutually exclusive classes. 4. Rectified linear unit, ReLU. The ReLU function is a nonlinear activation function that has gained popularity due to its simplicity and effectiveness. It sets all negative inputs to 0 and keeps positive inputs unchanged. ReLU helps introduce non-linearity into the neural network, allowing it to learn complex patterns and representations effectively. 5. Hyperbolic tangent, tanh, function. The hyperbolic tangent function is similar to the sigmoid function but maps the input to a range between -1 and 1. It is useful in situations where the output needs to be centered around 0, as it has a symmetric property around the origin. 6. Exponential linear unit, ELU. The ELU function is a variant of the ReLU function that handles negative inputs more effectively. It smooths out the negative region, reducing the likelihood of dead neurons and allowing the network to learn more efficiently. 7. Other activation functions. There are numerous other activation functions, each with its own advantages and disadvantages. Some notable examples include the leaky ReLU, parametric ReLU, PRELU, maxout, and swish functions. These activation functions offer different properties and characteristics, catering to specific requirements of neural network architectures. The choice of the top function has a significant impact on the neural network's performance. It affects the network's ability to learn and represent complex relationships within the data, the convergence speed during training, and the overall generalization capabilities of the model. In addition to the top function, it is also essential to consider other factors in neural network algorithms, such as weight initialization, regularization techniques, optimization algorithms, e.g., gradient descent variance, and architectural choices, e.g., number of layers, nodes per layer. These factors collectively contribute to the neural network's ability to learn and make accurate predictions. In conclusion, the top function is a vital component of neural network algorithms, determining the output or prediction based on the input provided to the final layer. The selection of the top function depends on the specific problem being addressed and the desired properties of the output. Different activation functions offer distinct characteristics, such as non-linearity, smoothing, or probabilistic interpretation, which influence the neural network's behavior and learning capabilities. The choice of the top function should be guided by the nature of the problem and the type of data being processed. Moreover, It is worth noting that the top function is not limited to a single activation function. In some cases, a combination of activation functions can be used in the output layer, allowing for more flexibility and capturing complex relationships in the data. For instance, a neural network may utilize a sigmoid function for binary classification and a softmax function for multi-class classification. The top function is closely tied to the loss function used during training, as it determines the measure of error between the predicted output and the true output. The choice of the loss function depends on the specific learning task, such as mean squared error, MSE, for regression or cross-entropy for classification problems. The top function and the loss function work together to optimize the neural network's parameters during the training process, aiming to minimize the error and improve prediction accuracy. It is important to highlight that the selection of the top function is not a one-size-fits-all approach. It requires experimentation and empirical analysis to determine the most suitable activation function for a given problem. Factors such as the data distribution, model complexity, and computational efficiency should also be considered when choosing the top function. In recent years, advancements in neural network research have led to the development of novel activation functions that aim to address specific challenges. These functions often incorporate adaptive or learnable parameters, allowing the neural network to adapt its behavior based on the data it processes. The choice of these advanced activation functions should be based on their performance on specific tasks and their compatibility with the overall network architecture. In summary, the top function in neural network algorithms is a critical component that determines the output or prediction of the network based on the input provided to the final layer. The selection of the top function depends on the problem being addressed and the desired properties of the output. It is an active area of research, and various activation functions exist, each with its own advantages and disadvantages. The choice of the top function should be guided by empirical analysis and experimentation, considering factors such as the data distribution, model complexity, and computational efficiency. Thanks for watching.